I'm the moderator of your session. So if you have any query or any update, write me in the chat box. Uh, on behalf of Global Knowledge Access Foundation, it is my great pleasure to welcome you to the sixth international conference on information and communication technology for intelligent system through Zoom. Further, as you all aware, we have been facing new normal situations over pandemic, and the conference has been shifted in hybrid mode. We hope you will enjoy knowledgeable and interactive sessions through the day. Uh, we also hope to have you at future physical conference. Also, there is a special note for presenters. You will be given 7 to 8 minutes for presentation and 2 minutes for question and answer. On 7 minutes, I will raise a gentle reminder. Uh, and I request while the presentation is going on, all participants kindly be muted. Just before we get started, I would like to introduce to all the chair for this session, Professor Latika Desai. Just a minute. Professor Latika Desai is the formerly working as an associate professor in the Department of Information Technology. She worked as a HOD of Department of Information Technology. She is working as a faculty since 2001. She has been total 24 years of the teaching experience. She has published 29 papers in various journals. Web of Science, Springer, International journals and conference. Her patent published in the Patent Office Journal and two copyrights from the Government of India. She received fund from ICTIS, New Delhi. Her organizes the national conferences, emerging trends and application in machine learning, sponsored by AICTE New Delhi. She is approved PG teacher by SPU. Uh, Welcome, ma'am.
Thank you, sir.
So now I will like to start with the presentation. Our first presenter is Dupinder Kaur, and her paper title is Master Data Management Maturity Evolution, a case study in Educational Institute. You can start the presentation.
Good morning, everyone. Sir, am I audible?
Yes, you can start the presentation.
Yeah, thank you so much, sir. So, good morning. The topic of my presentation is Master Data Management Maturity Evaluation, a case study in Educational Institute. I am Dupinder Kaur from Sirsa, Haryana. And before start my presentation, I would like to present an overview that what I will present today in my presentation. So I have worked on master data management. Master data is the critical data of the organization, which includes the data of customers, clients, suppliers, vendors, products, items, etc. All kind of the information is related in a single repository with the help of master data management. So in master data management, how an organization can implement MDM and up to what level it can be implemented. Um, there are the various model to measure implementation of the MDM in an organization. I have used Spritz MDM model to measure the effectiveness of MDM. So let us first discuss what is master data and what is master data management. Master data addresses the essential business entities of the company. I said that master data is the data of the customer, products, suppliers, or items. Now, the important thing is we want to present the data in a single repository or a single version of the truth where I can access each and everything of the person. For example, if I talk about the product ID, the product name, product delivery date, number of the items related to the product present in the organization, each and everything related in a single repository. This is the master data. Now, what is master data management? Master data management consists of set of processes, disciplines, and technologies to manage this master data. It includes various steps from the gathering of data, to clean the data, to integrate the data, and to govern the data, to manage the data, and finally, and to deliver the data to the customer end. MDM consists of all the processes and all the disciplines. Now, what is master data maturity model? Now, it is a standard estimation which can be used to measure the effectiveness of MDM in any organization. That is, up to what level MDM has been implemented in any organization. So, there are various models to measure the MDM effectiveness, but in my research, I have used SPRITS MDM models. MD3M model, that is master data management maturity model. It has been used in the present research. So what are the various other factors have been included in this research? The first thing is the capabilities of MD3M model. Basically, 5 key topics are included in the MD3M model. These are the data model, data quality, usage and ownership, data protection, and maintenance. The things that are related to the various key factors are: first is data model. The data model consists of the information like the type of data to be considered as master data, what type of the information to be stored in the master data, the structure of the data, and the storage location. These kind of the information is stored in the data model. The next is data quality. Data quality indicates various methods of access and the ways to enhance the data quality. The main stress is on the quality of data, that how we can improve the quality of data, or how we can access, or how we can clean the data. The next is usage and ownership. This key topic main focuses on the ownership grants, the access grants, the right and read access grants of on the data. All these kind of ownership grants are accessed in this key topic. The next one is data protection. Data protection concentrates on privacy and security toward the various kinds of the things that can enter into the system. That is how to protect the data from the viruses, hackers, and other kind of failures. The next one is maintenance. The main key focus on the physical storage of data, that is how we can maintain the data during its life cycle, and what are the various ways to maintain the effectiveness and efficientness of the data, how we can store the data in the efficient manner. Basically, SPRITS MD3M model considered these 5 key topics. Now, in my research, I have utilized these 5 key topics, and using these 5 key topics, I have analyzed that whether MDM have been implemented in my organization or not. So, in according to this 5 key capabilities, and additional maturity levels have been considered in this research. Basically, to measure the effectiveness of any software in any organization, we have 5 different levels. The first one is initial. In this level, any kind of the problem related to the MDM have been arised in the organization. The next one is repeatable. The issues related to the MDM started to resolve in this stage. The next one is defined. The teamwork of the different departments started to resolve the MDM issues. And the next one is managed. Here, the well-described documents started preparing related to the MDM, and these are also communicated in the various departments of the organization. And the last one is optimized. This includes the effective implementation of MDM. So in my research, I have utilized these 5 key levels with the 5 key topics that we have discussed. Now, I have performed a case study in my organization. The data has been collected from the various departments, and a case study has been performed. So these are the results of some case study. The table 2 represent the influential factor answers in the case organizations. These questions have been taken from the SPRITS model, and the answers are given by the experts of the MDM. So what the table represent MD3M maturity matrix result. Among these 5 key levels, the key topics are represented and the entries are represented as 1 and 0. 1 for the implementation of the key topic and 0 for the not implementation of the key topic. On the basis of the table 2, the answers of the influential factors, table 3 entries are filled. So in the data model, the first key topic, we have considered 3 further key subtopics: the definition of master data model, and data landscape. Among these, we have analyzed that at the level 5, data landscape is not applicable in my present research. And in the data quality, 4 sub-key topics are considered: assessment
Dear
of data
presenter, sorry to
quality.
interrupt. You have last 2 minutes.
Sir, sorry, sir.
You have last 2 minutes for presentation.
Okay. So on the basis of the MD3 matrix model, the results are represented. So here are the another results that I can say about my research. On the basis of the SPRITS MD3M model, 2 tables are formed. The first one is the percentage of applied and absent capabilities results by level, and the second one is results by the key topics. So the first table, the table 4, represents that initial level has total 13 number of capabilities, among which 13s are applied and 0 is absent. And the percentage level is also presented in the table. And the repeatable level has 13 capabilities, among which 11s are applied in my research and 2 are missing. And similarly, if I talk about the key topics in table 5, we have 5 key topics. If I talk about data model, there are 14 number of capabilities, among which 12 are implemented and 2 are missing. So the overall result is that among 62 capabilities, 44 are implemented in my organization and 18 are missing. This implementation represents that among the 62 capabilities of master data management, 44 are implemented and 18 are missing. So this is the overall maturity level of the organization. The 5 key topics overall represent the maturity level. The key model, the data model is at level 4, data quality is 1, usage and ownership is at 1, protection is 3, and data maintenance is at 2. How we can check that at what level these key topics are? This is represented with the matrix level. For example, in the data model, if I talk about definition of master data, it is maximum at level 4, and the master data model is at level 4 and data landscape is at 4. So the overall level for data model is 4. But if I talk about data quality, the minimum level for impact on business is 1. So the overall level for data quality is 1. And similarly for usage and ownership, the minimum level is for the data usage is 1. So the overall maturity level is 1 for usage and ownership. So similarly, this table has been formed. So the result or the conclusion of my research is that we can use various kinds of the maturity model to access the implementation of MDM in any organization. I have used SPRITS MD3M model to access the implementation of MDM in my organization, and I have found that among 62 capabilities, 44, that is 70%, are implemented, and whereas 18 are missing in my organization. So by utilizing these kind of analysis, we can perform various kinds of analysis which will help the organization to improve their data quality, to improve the data maintenance, and we can focus on the missing capabilities so that we can enhance the data in the future also. So thank you so much. So please, anyone, if they have doubt, they can ask.
Okay, nice presentation, Dupinder.
Thank you so much, ma'am.
I have one doubt, that is, there are 13 different models. You are serious?
Ma'am, 13 key topics, ma'am, actually. Key
Okay.
topics.
So you are focused on one, right? No, 13 Go to the first slide.
Yeah, ma'am, sure.
Yeah,
This one?
yes. No, next one. This 13
Yes, ma'am.
focused areas, right? And you are
Yes,
focused on
ma'am.
5 key topics, right? So how
Yes, ma'am.
we can measure the effectiveness?
No, ma'am. I talked about that with the 13 focus area. I have utilized 5 key topics, a combination of both, ma'am. 5 key topics as well as 13 key focus area. Okay, ma'am. I will show you with the table this one.
Okay.
You can check in the table 3 that there are 5 key topics. The key topics are data model, data quality, usage and ownership, data protection, and data maintenance. These are the 5 key topics. And the
Okay.
focus areas are further divided. For example, in the data model, I have 3 focus area. In the data quality, I have 4 focus area. Assessment of data quality, and similarly for usage and ownership, I have 3 data focus area. So this 13 focuses area and 5 key topics in combination with 5 different key levels.
Yes, but what I'm saying is how we can measure the effectiveness of it.
Okay, ma'am, I have analyzed that in my organization whether the definition of master data at level 1 is filled or not, it is completed or not. So I have
Okay.
put entry 1 that it is completed. So
Okay.
similarly, yeah, ma'am.
I
Yeah,
got it. Now,
yeah.
just tell me related with the security.
Related to the security.
In the level 4, it is 0. So can we increase that?
Yes, ma'am, definitely we can provide the security because data governance, it is a part of master data management. In my research, I have implemented data governance up to a certain level. That is, it is represented that up to the level 3, it is secured. But data governance help us to provide the security. We can assign a person which can provide the access to the various kinds of persons, that whether they are allowed to access the data or not at the different situations. So in this way, we can provide the security.
Okay, Dupendra, thank you.
Okay, thank you so much, ma'am.
Jay, sir?
Yes, madam. There is another request for all participants that you all stay connected with us till the closing remarks. So now moving on next presentation. Ronak Kumar Patel, and his paper title is Addressing Item Cold Start Problem in Collaborative Filtering Based Recommendation System Using Auxiliary Information. Ronak, are you there?
Yes.
You can start the presentation.
Yes, so very good morning to one and all present here. Our paper ID is 88 and our paper title is, I hope I am audible.
Yes, you can.
Yeah. So our paper ID is 88 and paper title is Addressing Item Cold Start Problem in Collaborative Filtering Based Recommender Systems Using Auxiliary Information. Myself, Dr. Priyank Thakkar and Ronak Patel are authors of this paper. Next. So this is the outline of our presentation. We will start with the basics of recommender system and item cold start problem. Then we will discuss about how we can address this item cold start problem. And finally, we will conclude our presentation with some potential future research directions. Next. So the first thing is, what is recommender system? So recommender system is a personalized information filtering technology used to do either predict whether a particular user will like a particular item, or to identify a set of n items that will be of interest to a certain user. Next. Now, there are different types of recommender systems, like collaborative filtering based recommender systems, content based recommender systems, and hybrid recommender systems. Over here, our focus is on collaborative filtering based recommender systems. So there are two subtypes of collaborative filtering based recommender systems. They are user based collaborative filtering and item based collaborative filtering. In case of user based collaborative filtering, target user is recommended items which other like-minded users have liked in the past. While if I talk about item-based collaborative filtering, in that target user is recommended items which are similar to the items liked by the target user himself or herself in the past. So this is the difference between UBCF and IBCF. Next. So now the main question is, which we are trying to address, actually, item cold start problem. So what is item cold start problem? So whenever we have any recommender system and a new item or product is added into the system, obviously there are no ratings or very few ratings available for the for that item. Now, in case of item-based collaborative filtering, we need to find the similarity between items, and based on the similarity between items, we actually come up with the recommendation. So quality of the similarity, how well we can calculate similarity between items actually affects the quality of the recommendation. Now for the new item, as we do not have enough ratings and we calculate similarity typically using ratings, similarity calculation will not be good enough, and therefore recommendations will not be good enough. So this is a typical problem with new items in the recommender systems, which is known as cold start problem. So what we propose in this paper is that we can use auxiliary information apart from ratings. Typically, we calculate similarity based on ratings, but what we are proposing is that in addition to ratings, as we have auxiliary information available for the item, we can also use them in the calculation of similarity. And we can come up with better estimate of the similarity and therefore better recommendation. If I talk about auxiliary information about the item, like we can have textual description related to the item, or we can have image of the item or audio or video related to the item. So these are different types of auxiliary information which is related to item. So in addition to the ratings, this 4 types of auxiliary information can be utilized to come up with the better estimate of the similarity and therefore better recommendation. Now next is problem statement and our proposed approach. So I request Ronak to take the presentation further.
Yes, sir. So am I audible?
Yes, Ronak, you are audible.
Okay. So now problem statement and motivation. So the problem statement is to use this auxiliary information related to users and items to address the cold start problem with new items. And basically we'll focus on text and image. So motivation is the traditional recommender system heavily rely on user item rating metrics to make a recommendation. And the sparsity of this rating metrics result in poor quality recommendation and cold start problem with new users and items. So proposed approach. So this is a new items which are added in the system, and there are no ratings available for these items, but the images and text related to those items are available, like description, the image, picture of that image that is available. So we can use those features to find the similarity between the items. So once we have those features from image model or text model, we'll find out the similarity between items. Once we have the similarity between items, what we'll do, we will find out the top similar items with the target items and those items in the past rated by the user. So suppose if I want to predict for item 5, then I will find out the similar items to item 5 which is rated by the target user. So after that, I will predict the rating, and then most the items who has a high rating, that items will be recommended. So this is our proposed approach. Experimental setup. So we will check in 3 different with the 3 different methods. So method 1 is only image features. Another is method 2, that is with text features, and method 3 will combine these features and then we'll check the similarity. So this is basically to find out the similarity between items, one with only image visual features, one with textual features, and another is combination of that. Rest is same. So data set, we have used the Amazon data set, and these are the some of the overview of that data set. So there are other categories are available in that data set, but we have chosen the Amazon clothes, shoes, and jewelry data set. So some statistics of this data set. So number of ratings are 5 and such items are 5,123. So 5,123, there are such items who has 5 ratings. And there are 15,558 users who has given 5 ratings. Similar way, 6, 7, 8, 9, 10 up to 15. Rating prediction. So to find out the similarity, we have using this, and to predict the rating, this equation we have used, and this is memory based equation. So this basically says that you want to predict the rating for user U for item I, right? Evaluation measure, we have used RMSE and MAE, as MAE don't focus on outliers, so we have included RMSE as well. Experiment result, so these 3 method M1, M2, M1 is only visual feature, M2 is with text feature, and M3 is combination of visual and text feature. And these are the setups, means we have taken into consideration the items who has been rated, means number of times 5 or less than that. 6 means it will include 5 and 6. 7 means it will include 5, 6 and 7. This way we have set up the experiment, and for this 7 setup we have evaluated our model, and we can see the RMSE and MAE. As number of ratings are increasing, RMSE and MAE are also increasing, right? So when your ratings are number of ratings given to items are less, at that time this auxiliary information are more useful, and when the ratings are increasing, at that time the auxiliaries information based prediction are affecting. So conclusion is, we in this paper use auxiliary information to engineer features of cold start pro items, and we use deep neural networks such as pre-trained VGGNet to fetch the image features, and BERT to extract the features from text. And we found that all the models enable collaborative filtering based recommender system to recommend new items with reasonably low error rates. The performance of these 3 models, M1, M2, M3, however, did not differ significantly, and this necessitates a more thorough analysis, but it does not present an intriguing potential research opportunity. And in future, we'll also try with a new user. So user cold start problem is also an interesting problem which can be explored in the future. So that will focus. And these are the references. Thank you. Any questions?
Okay, Priyank and Ronak, a
Yes,
nice presentation with analysis. Just
Thank
I
you.
want to ask one question. You made that analysis, right? Have you compared your analysis with any other author's work with the same area?
Okay, so this new item problem, we have not compared with any other, because with the new item problem, what happened, if you go with the normal collaborative filtering, we could not find a rating anyway. Means there will be no rating prediction for new item if we go with the traditional rating prediction. So then we are using this auxiliary information, which is image, text, and the combination of this. So we have compared those auxiliary information, because other what I can say, other researchers, they have used some other metadata that is available with the data set. So that comparison is not done, but we have taken our different models.
So it's like we have actually adopted a totally different approach, and actually no one has tried to use this kind of auxiliary information to compute the similarity and then provide the recommendation. So therefore, means one-to-one comparison was difficult. So therefore, we thought that let us compare our performance of only visual models, only NLP models, and then their hybrid combination. That was our idea.
Okay, okay, Priyank. Auxiliary input you are taken, right? That is text and image only, because
Yes.
videos and audios you are not included, right?
Yes, ma'am.
Okay, okay. Thank you. Thank you.
Yep.
Thank you, ma'am. Thank you.
Moving on, next presentation. Ganesh, and his paper title is Space Model Generation Using Deep Learning. Ganesh, are you there?
Yes, yes.
Yes, you can start the presentation and keep it in time.
Yeah. Yeah. Good morning, everyone. Hope I'm audible and you can all see my screen. So I
Yes.
am Ganesh Manindra, and I'll be talking about our research on face model generation using deep learning. So first, I'll start off by telling what we mean by face generation. So it is basically the task of interpolating or generating new faces with the help of an existing data set of images. So these generated images are widely used in creating games, in creating animations, and they're also used in espionage for creating fake identities for spies and defense officers. So for achieving this in our research, we'll be making use of a type of a generative adversarial network, also called as GANs. So GANs use unsupervised learning that involves automatically discovering and learning patterns in input data. And this can be used to generate outputs that are similar to the original data set. Now, we will be using deep convolutional GANs, which are very similar to GANs, but they use convolutional networks instead of fully connected networks that are used in GANs. So the goal of this research, the research that we have done, is to use deep convolutional GANs to create fake face images. So the reason behind choosing deep convolutional network is deep convolutional networks help in finding the spatial correlation in images. So these networks are ideal and they are preferred for image data. Okay, so now let's deep dive into how like GANs work. So this model basically works as a team of two networks, the generator and the discriminator. So the generator network is given a noise vector as an input. Then it runs this noise through the network and it reshapes it to have a recognizable face image similar to the ones in the data set. The generator network architecture consists of a fully connected layer followed by 4 convolutional layers. After passing each layer, the height and width becomes double. So at the end of the network, we get an image of dimensions 32 cross 32 cross 32, which is the size of the image in the data set. And we use ReLU activation function for the hidden units. Yeah, this is the discriminator network. It is a classifier network that outputs the probability of an image to be real. So this network is shown images from the training data set and the images generated by the generator. Its target is to assign probability near 1 for real images and near 0 for fake images from the generator. So this network's architecture includes 3 convolutional layers followed by one fully connected layer, which outputs a single logit. So this logit defines if the image is real or not. For the hidden units, leaky ReLU activation function is used. So here you can see the general architecture of both the generator and the discriminator. So the generator creates, here you can see the generator creates fake images, and this fake images along with the real images from the training data set is given to the discriminator. The discriminator's target is to assign 1 for real images and 0 for the fake ones. So on the other hand, generator tries to generate fake images for which the discriminator would give probability close to 1. So as the training goes on, the discriminator will get better at classifying real and fake images. And to fool the discriminator, the generator is forced to improve to generate more realistic images. So now we calculate the loss of both the generator and discriminator. So for the discriminator, the total loss is the sum of the loss calculated on real images and the loss calculated from the fake images. And the generator's loss will be similar, but with flipped labels. That is, the loss will be the real loss obtained from the fake images. So this is the graph for the loss functions. Here you can see the orange line is the generator's loss. So there's a high fluctuation here because the input to the generator network is a batch of random noise filters. So the fluctuation you can see here decreases towards the end because it starts to fool the discriminator. In the discriminator plot, we can observe there's a rise in the training loss followed by a decrease towards the end. This means the generator started giving some very realistic images towards the end. But the discriminator becomes better at classifying them. So the discriminator started classifying fake and real images better towards the end. So the loss decreases. So here there are a few of the fake images that were created from our model. So here we observed that the images were generally lighter in shade. So this is because our data set, we use a data set celeb A. So in this contains celebrity images, which are mostly white. So the model can be improved by using a wider range of variety of images in the data set. Also in this data set, only frontal view of the faces are available. So which limits the model to create faces from only the frontal view. And future research could be done on this. This framework can be extended to audio and video, audios and video domains too. These are some of the references. And yeah, that's it from me and my team. Thanks a lot for this opportunity. And yeah, thank you.
Ganesh, nice presentation. But
Thank you.
Which data sets you are handled?
We have taken data set called Celeb, which is face images of celebrities.
Okay. Now, can you try for the other also?
I'm sorry. How can you repeat?
Can you try for the other data sets also?
Yes, we can take other data sets with image data with faces.
Okay.
But yeah.
Okay. And how you are handling the noise?
The noise which we input into the generator. Are you talking about that?
Yeah.
Yeah, the noise, the generator network is trained, like when you give the noise, the network, the convolutional networks, they double the noise after each layer. So when it comes out as a picture. So first it's a noise, then the first layer doubles it becomes 2x2 picture, and then it becomes 4x4, like so on, and then it comes out as a 32x32, which is basically the size of the image in that data set.
Okay. Thank you, Ganesh.
Thank you all.
We are going next presentation. Neha Banu. Paper title is Text-Based Prediction of Heart Disease Doctor Chatbot Using Machine Learning. Neha, are you there?
Yes, sir. I'm sharing.
Yes, you can start. Hello.
Am I audible?
Yes, you can start.
Is it visible?
Yes.
Good afternoon. Myself Neha Harlapur and my teammate is Vidya Handu. We are from KLE Technological University, Hubballi. My problem statement is text-based prediction of heart disease doctor chatbot using machine learning. The contents are as follows: introduction followed by the related work, that is literature survey, whatever I have done previously, and what is the overcome method I have used. Then the objectives, methodologies, results, conclusion, followed by the references. Introduction. As we know, a doctor chatbot is like we need not go and visit a doctor. We can access it through easily through the mobiles wherever we are available. By this we can say that it will reduce our time and everything. The objective is to develop a text-based system that can predict the heart disease using a Dialogflow is a API that is governed by the Google App Engine, which is a front-end part. And I have used SVM algorithm to classify the data set and to predict whether the person is suffering from heart disease or not. The data set is taken from the Cleveland heart disease data set. After doing a literature survey of numerous papers where they have used different algorithms like ngram, TF-IDF, random forest, where the resulting accuracy resulted was less than 90%. The comparative analysis was to overcome the result of the literature survey and use different algorithm. The main objectives are to design the UI, that is user interface, that will collect the information of the user remotely and to predict whether the user is suffering from the heart disease or no by giving a form where user can fill by pre-existing scan report to measure the accuracy of the predicted results. And if the results are predicted, he can book or appointment on the with the nearby doctors available. This is how the proposed methodology works, where the user inputs to the doctor chatbot. That is, before doing this, we need to create a Dialogflow API with the agent called doctor chatbot. Then we add the intents and entities. Intents will be followed by the number of the attributes present in the data sets, like it may be the male or female, it may be the heart, resting blood pressure, it may be the sugar level, it may be the colonoscopy done. Then the user asks the questions, prompts the question to the doctor chatbot API, then where the doctor chatbot API suggests some of the predictions from the previous diagnostic results, where if the predictions are compared with the user and if they are similar, then it will suggest some of the list, it will suggest to fill a form, where after filling the form the accuracy is measured and list of doctors are given by using SVM algorithm. And we have used feature attributes like age, cholesterol rate, fasting blood pressure, resting blood sugar. There are 14 attributes from the Cleveland heart disease dataset, and the resulting output is whether the user is having the heart disease or no. Here, as I said, user logins into the system and then has queries related to the heart disease. Then he starts predicting the symptoms based on the user prompting the questions to the Dialogflow API. Then the accuracy of the result is measured. Here are the results, where first he need to fill the login page and enter into the doctor chatbot API. Then with the help of the data set, the report form is created based on those attribute values, where the symptoms are predicted by filling the form. And then here we can see, like, the chatbot prompts some of the questions like age, his name, and everything. Then the form is submitted. After submitting the form, the user needs to book an appointment with a doctor if he is suffering from a heart disease, or if the symptoms are not predicted or matching with these whatever he is prompting the questions, then he will say that you're fine, you need not worry, you need to follow this some of the appetite like exercise or something else. These are the result of heart disease, where heart disease can be found more in females rather than males, and this is the target value, where no disease and disease is classified based on the chest chest pain type, that is agenal type or it is non-agenal type. This is the accuracy measured where I have used 3 different methods, algorithms, SVM, k nearest neighbor and naive Bayes. According to my results, SVM outperforms well by the accuracy of 96%. Conclusion is that it also responds with a disclaimer: please do not depend on always do not depend on this doctor chatbot. But when we are some eagerly approaching doctor and he is not available for some time, we can use this in that scenario, and if we have the earlier diagnosis report, with that we can suggest the doctor chatbot, and it can be applicable for the future enhancement will be, it can be applicable for the many other diagnoses related to the not only for heart disease, for any medical imaging diagnosis. The results of the SVM are achieved with the accuracy of 90%. These are the some of the references. Thank you.
Your topic was good, Neha Banu.
Thank you, ma'am.
Actually, while collecting the information, have you faced any problem?
Like collecting the information, it was yeah, ma'am, like whatever type of like what will be the patient's requirement, we will be not knowing.
Okay.
Then we visited some of the nearby hospital, then we collected the information.
Okay. And 3 comparison algorithms you have shown, no?
Yes, ma'am.
Last.
SVM, k nearest neighbor and
Yes.
naive Bayes algorithm.
So all 3 you are implemented?
Yes, ma'am. According to that, SVM only outperformed well, ma'am, because the accuracy rate is increased in SVM, and where k nearest neighbor and naive Bayes algorithm, the accuracy rate is too low, ma'am. And k nearest neighbor is like only 50 to 60%, ma'am, when we train the data set.
And what about the time complexity?
For 15 epochs, ma'am.
Okay. Thank you, Neha.
Okay. Thank you, ma'am.
Moving on, next presentation. Vamsi Krishna, and his paper title is Combining Variable Neighborhood C and Consent Programming for Solving the Dial A Right Problem.
Yeah, I'll share my screen. You can see my screen, right?
Yes, you can start.
Okay. Hi everyone, my name is Vamsi Krishna. Our title is Combining Meta Heuristics and Constraint Programming for Solving the Dial-A-Right Problem. This work has been guided by Dr. George Gutier. So these are the contents. So basically we are trying to solve the Dial-A-Right problem. So what the Dial-A-Right problem is, a very much constrained version of traveling salesman problem with time windows. So here our goal is to manage the transportation of very scattered clients and pick them up and drop off in whichever request they are presenting. This is as you know, TSP in itself is NP hard, but this is even several folds harder than that in terms of time complexity. So from the beginning, there are many algorithms that are being proposed. The very first one being, I think, the branch and cut algorithm, which is a exact algorithm for solving this particular problem. We'll see what other algorithms are there and what we have presented. But firstly, we'll try to more formally define what a Dial-A-Right problem is. So, in essence, as I said, TSP with time windows, that is a more basic version. And after that, we have vehicle routing problem with pickup and delivery. So what this is, is we have a fleet of vehicles and a bunch of customers distributed across a particular geographic location, and they request for either a pickup from a particular location to one particular destination where this is to be delivered. So that is the vehicle routing problem. Whereas the dial ride problem is more or less similar to this VRPPD, but with time windows. So what time windows is um, the user will not accept the ride or a pickup unless it is within his or her particular specified time window. So this kind of formulation is very much suited to the real world, not very theoretical, so to speak. So this has been widely used in literature where specially abled need to be delivered or picked up from a particular location to the hospital or vice versa. Here, many kind of special cases are also considered, like one particular set of patients need a particular vehicle and the other set needs another vehicle, which is called as heterogeneous fleet, basically, which is like not every vehicle is same in the entire fleet. And also it extends to pooling of rides. Pooling of rides is basically Uber pool or ride sharing, where already there will be some customers in the vehicle, and based on the possibility, some more can be added or removed in that particular route. So that's the dial ride problem. And as I said, there has been very exact algorithms proposed, but we look for more scalable solutions because the exact ones don't scale that well. We look for heuristics or meta heuristics to solve them a bit more efficiently. And in our case, we are looking towards variable neighborhood search, which is a meta heuristic framework. And in this particular meta heuristic framework, we are looking at why we are using constraint propagation as a part. So constraint satisfaction problem is where we have a bunch of variables, and we are trying to find a feasible solution given all of the constraints that it needs to satisfy, that each and every variable need to satisfy. So there is no optimization in this particular constraint propagation framework. So we don't use it solely to solve the problem. We use it in the variable neighborhood search meta heuristics to solve a particular sub problem. We'll see what that is. Yeah, this constraint programming is basically something like backtracking, where we check most of the possibilities uh, for the variables from their domains, and we keep on iteratively shrinking the domain so that we find one particular feasible solution. That's the goal for constraint programming. So as I said, we use that in variable neighborhood search framework. So this has been used not only to solve the dial ride problem, but in many combinatorial optimization problems that we have seen before, like VRPPD or TSP with time windows, etc. It is an iterative technique, and there are basically three phases in the VNS. So one is we start with a initial solution, and because it's iterative, there will be one overhead loop, and we'll keep on randomly shaking the solution, which basically means that we remove one part of the one node in the solution and add in another node, and we take that solution and we perform a local search on it. And in this local search, we use only one operation called to-opt, which basically finds out what the best local solution is in its neighborhood. And if this newly found out solution is any better than the solution that we currently have, we take this solution as our new best solution, or else we go to the next neighborhood and repeat the same process. So where the constraint programming comes into picture is to find, actually this can also be used in multiple areas inside the VNS algorithm itself, to find the initial solution in the shaking phase, and also to restrict the local search space. But in our particular algorithm, we used it to find the initial solution. So this S0, this initial solution is the output of the constraint satisfaction problem that we formulate. And this local search is there are many kinds of local searches, because these meta heuristics have been here for a while. But we use what's called best improvement strategy, where the entire neighborhood is explored and the best in the local neighborhood is found out. So for comparison sake, we implemented two algorithms. One is a basic variable neighborhood search with the cheapest insertion for the solution, and the other one is where the initial solution is generated by the constraint program. All of these were implemented in Python, and Google OR Tools is the package that we've used for constraint programming. And this has been run on Google Colab notebooks with K80 GPUs, 1 K80 GPU actually. The dataset is a standard benchmark dataset taken from this particular paper. As I mentioned, this is one of the very first algorithms proposed, the branch and cut algorithm for this dial-a-ride problem. And this is the paper which proposed the benchmark dataset. So the results. What we have done is we have taken two scenarios. One is because this VNS is a meta heuristic and it is iterative, we can either put a number of iterations as a limit or the time as a limit. Instead of finding what the best solution is, giving more number of iterations, what we did was
Dear presenter, sorry to interrupt. You have last 1 minute.
Yeah, I'm done almost. So what we did is we've taken time limit and compared it with double the time limit for the VNS without CP. So basically 100 here means this 30 seconds with CP is equivalent to 100 is equivalent to the 60 seconds without CP. So this is twice as fast as without using CP. So we approximately get 2x boost in performance. 112 here means this is 12% even more than twice the performance which is given with CP. And these are the datasets that we've used. So to conclude, there has been a lot of potential in this, and we also can use reinforcement learning models to solve this dial-a-ride problem. We actually proposed and published one algorithm where we use reinforcement learning to solve the capacitated vehicle routing problem, which is a less constrained version than the dial-a-ride problem. This is more implementation intensive, so we look towards meta heuristics for time's sake. But reinforcement learning can also be used, and they are proving really efficient too. Yeah, and thank you, and I'm open to questions.
Vamsi, your presentation was informative.
Thank you, ma'am.
You are taken for the result, no? Double time, right?
Yeah.
Can you tell the reason behind that?
Yeah, because if we take equal time, like 60 seconds and 60 seconds, every number here will be something like 49 or 49.5 or something like that. To zoom it a little further, we try to even exaggerate by taking half the time and showing that it is clearly twice as better.
Okay, Vamsi, thank you.
Shall I stop sharing, or are there more questions?
Yes, you can stop.
Thank you.
Our next presentation is Kulal Srivastav. His paper title is Air Quality Prediction Using Supervised Machine Learning Techniques. Are you there, Atul?
Yes, sir.
Yes, you can start the presentation.
Good afternoon, everyone. My research topic is air quality prediction using supervised machine learning techniques. These are the contents: introduction, AQI category and health issues, methods, results and discussion, conclusion, and references. Introduction. So these days, the level of pollution in the air has surpassed fundamental levels, and the amount of contamination in several major urban areas has exceeded the public authorities' air quality list criteria. This PPT we describe a device that can collect the current toxic gases with the help of previous records of toxic gases. We executed a computation using machine learning techniques to detect the contamination in the air. It would be a good idea to use machine learning to forecast the future contamination information. Problem statement: to build a prediction model for the target pollutant in the city with sufficient training data. This is the AQI index. If the value is between 0 to 50, then it is good. If it is 51 to 100, it is moderate. 101 to 150, unhealthy for sensitive groups. 151 to 200, unhealthy. 201 to 250, very unhealthy. Methods: linear regression. I've used linear regression, decision tree, and random forest. Linear regression is one of the easiest and most popular machine learning algorithm. It is a statistical method that is used to predictive analysis. Decision tree is a supervised machine learning technique that can be used for both classification and regression problems. It is a tree structured classifier where internal nodes represent the feature of a dataset, branches represent the decision roots, and each leaf node represents the outcome. Random forest. Random forest is the popular machine learning algorithm that belongs to the supervised learning technique. Random forest is a classifier that contains a number of decision trees on various subsets of the given data set and takes the average to improve the predictive accuracy of that data set. The greater number of trees in the forest leads to higher accuracy and prevents the problem of overfitting. Sorry. It can perform both classification and represent tasks. Here you can see this is the graph of carbon monoxide. This is probability prediction of O3. In probability of prediction of CO and O3, random forest gives the more accurate result. Here you can see 0.81 and 0.75. Conclusion and future. The goal is to build the prediction model for the target pollutant in the city with sufficient training data. In future, we can build prediction model with more accurate result. That's it. Thank you.
Thank you. Thank you, Atul, for the presentation.
Madam, any questions?
No, next.
Yes. Next presentation is Angeline. and our paper title is a survey on extra stream mineral data analysis in geological location using deep learning.
Yes, good morning, everyone. Let me share my screen.
Yes.
Good morning, one and all present here. I'm here to present our paper, Exploratory Mineral Data Analysis on Geological Location using Deep Learning. And moving to the objective of our project, the main objective of our project is to eliminate the traditional way of exploring minerals. That is, nowadays, what we do is we actually dig over the soil up to few meters or the thousands of meters to explore whether the mineral is present or there. So we thought of simplifying it, and that's what we have made in our paper. And we are using RNN algorithm, which is in deep learning. And coming to the introduction of the project, as I said before, nowadays the world's population is extremely rising again. So we are in need of excess of minerals, and that's insufficient in nowadays. So we thought of exploring the minerals from the earth in the similar way. So for that, we usually handle much more traditional methods in which we may not get a greater accuracy. So in order to avoid that, we have tried out our new way. So in this method, what we are going to do is we are going to get a seismic image, and from the seismic image, we are going to detect the mineral from that. And these are the existing system architectures and defects of them. So in existing systems also, we have some mineral exploring ideas. So in that we have faced these defects. So first one is classification accuracy, and computational steps are highly high. And we need more training data for existing systems. So in our proposed system architecture, this is the proposed system architecture in which we would pre-process the seismic images and extract the coherence matrix from that and extract the features, and we will train that with using RNN algorithm, so that we would get the mineral location of the mineral in that image. So we have split our projects into these modules, and the first one is image acquisition. The image acquisition is nothing but in which the seismic image is adapted. That is, seismic image is nothing but an geophysical image that is got by the reflected radio waves from the earth. So what we do is we will send a radio wave so that waves would reflect on the surface in the earth's crust and return back to that. We will record that with an instrument, and we would convert that into one image that is known as a seismic image. And this is technically done by Society of SEGY and standard technical commissions. And what we do is we will take that seismic image and use some pre-processing techniques like enhancements and grayscale conversion likewise, and we would pre-process the image. And later then we are going to extract the features in that image, and we will segregate it into the images with the mineral presence and non-mineral presence. So after that, we would use a RNN algorithm and classify that minerals from that. So as a conclusion, we would get an
खत्म हो गया.
excuse me. Okay. As a result, we would get an image and seismic image and where the mineral is located from using an RNN algorithm. And we use this RNN algorithm since seismic images are much more higher in memory, and RNN also has a feedback mechanism in which it would will be greater for sequential data. So as we send seismic images into a sequence of pixels, so we use RNN algorithm, and it could give us much more better accuracy. And this is our future works. What we are going to do is we have implemented this in a two-dimensional seismic image, and we are going to try that out in a three-dimensional seismic image so that we would get the results with more accuracy. And thank you.
Thank you, Anjali. Actually, can you show me that slide where you are mentioned which parameters you are enhanced, like accuracy, complexity?
Are you speaking about this?
Yes, yes, that only. So can you explain how much accuracy you are enhanced, as well
Uh,
as how much time complexity you are resolved?
Okay, ma'am. In the existing, we have got this effect from an project in which they have used the CNN algorithm. So in the CNN algorithm, they were the computational steps was much more higher compared to RNN. So from that point of view, we have reduce the computational steps in that, and comparing to the accuracy, we haven't implemented it fully, so we expect about 90% of accuracy in that.
Okay, okay, Anjali. Thank you.
Any other
Moving
queries?
on, next present.
Thank you.
G. Bhumika, and our paper title is a survey on detecting preventing hateful comments on social media using deep learning.
Yes, sir. I'm here.
Yes, you can start.
Yes, sir. So my screen is visible.
Not now.
Now, sir.
Yes, you can start.
Okay, sir. Good morning, everyone. I'm Bhumika. My teammates are Kartika, Anisha, Shalini, and Srivashni. My project title is A Survey on Detecting and Preventing Hateful Comments on Social Media using the Deep Learning. Objective of the project is nowadays most of the people spend the free time in social media. In social media, we see a lot of the hateful comments. Hateful comment means vulgar words, offensive words like that. Our project is take that comment from the user page and analyze that comment is a hateful comment or not, and prevent some condition to hide that comment using the natural language, using index mining and deep learning algorithm. Introduction of the project is the web-based media is the most popular and plays an important use of the people, and it here to share their thoughts, creativity, and other some instance. It have a lot of advantage and disadvantages also, like commenting vulgar words or offensive words in front of all age. It shows the negative impact in their thoughts, and so we are in our project we are detecting and preventing the hateful comments. This is our proposed system. In this, we have here two sides. One is admin side, another one is a user side. In the admin side, we are creating the UI for the admin details. In this, the admin in our project, we are admin only trying the detail of trying the positive and negative words of the in this project, and admin trying the negative words. It will be stored in the database. In user side, the user pages of the creator. In this page, it's like a social media, Instagram, in this we are having the post friend list, we enter. If the new user entering means login and using login and register, we enter the pages. It will be show the home pages. In this page contain the post friends like that. If you want to connect with any of the register user means send request that person. Next, you connect with each other. Your friends post any image or video means you comment it for that post. Means first the command automatically take and perform with the text mining concept and remove all stop words, keywords like remove that. After match with a database using the back propagation algorithm in deep learning. Next, the command will be and if the condition is satisfied, the command will be posted. Otherwise, command will be moved to the hateful comments. That hateful comments also having the two. One is accept or reject. If the user want to that is not that much of the hateful command means accept it. Once they accept it, that command also posted. Next, if the same command is again means sending the warning messages and block the user, send the notification to that person registered phone number. Our project fit into the summaries like this. First, in design way, first we're creating the website like social media pages, Instagram, and it will be help to create our exchange information and idea in each others. Next, take the command to that user pages. The command will be maybe in text or short text only. We are choosing only text format and images. The comments and sent to the server pages. Next, classifications. In this first and the character comments are first using the text mining concept to split and remove the stuff and keywords. Implement the backpropagation algorithm. Using the backpropagation algorithm, compare with a database and count how many present comment, and we are set some conditions like, for example, if you that person send a 5 time only the hateful means that compare with it that that person not exceed that limit means the comment will be posted, otherwise the comment will be hide. In this, we are setting some filtration rules. In this filtration rules means filtering of user comment post. In this process, I have to find how many hateful words present in the sentence and identify it. It tags facilities and send notifications about that and give permission to the user. And last one, in the alert system rules are generated by user for conditions. For threshold value means in this place we are setting the count. For example, how many times the person send the hateful comment. For example, say, in this we are setting 5 minutes. That same person 5 times only send the hateful comments. If the threshold value based on threshold value, we can block the friends and who are provide the negative comments. And once block that user, we send the mobile notification to that person registered mobile number. In this, I implement analyze the short text and automated blocking friend list also implemented from vulgar terms and send automated warning based on the threshold value also given, and mobile intimation to the user also given. And we analyze the emoji recognitions. In emoji recognition means we are provide the emojis. If your user want to give any emoji means we click it means that will be also show to the user. And also improve our design UI and alert system also provided. That's it. Thank you, ma'am.
Presentation was good, Bhumika.
Thank you, ma'am.
You are giving the warning with the help of threshold values.
Yes,
can you tell me the range of it?
Ma'am, in this threshold value is setting the count, ma'am. For example, in this for example, the same user sending the hateful comments in repeatedly means I'm setting 5 means that same person sending the 5th time comment in hate same user profile means we sending the warning messages, ma'am.
Okay. Thank you.
Thank you, ma'am.
Moving on, next presentation. Vaniami and her paper title is Anomaly Action for Bank Securities Against Theft Survey.
Yes, sir.
Yes, you can start.
Okay, sir. So is my screen visible?
Not now.
Sir, now?
Yes.
Okay, sir. First of all, good afternoon to one and all present here. I am Vaniami. I am currently doing engineering in the Department of Computer Science and Engineering at M. Kumarasamy College of Engineering. I am going to present about our survey on anomaly detection for bank security against theft. So these are the outlines: abstract, introduction, Gaussian mixture model, Haar cascade algorithm, video surveillance system, face recognition, and conclusion. First, abstract. The aim is to detect the abnormal event or activity in banking using surveillance video system. Automatic detection with alert system helps to enhance the performance of the video surveillance system. Abnormal event detection is one of the most huge objective in analysis sector and in application of motion picture intelligence. The improved public safety cameras are progressively being used in a broad daylight spaces like street, junction, banks, and shopping centers. One of the most critical limit in the video structure is preserving uncommon activity, for instance, accident, unwanted behavior, or other legal exercises. Next, introduction. The survey is for bank security using the time-based movement detection and face recognition from the video clips to still images. In this work, admin can set the time period for recognizing the face in the video. During video capturing in abnormal period, that will check the movement present in the video using Gaussian mixture model. If movement was detected, that will send an alert notification to the pre-selected numbers or pre-selected emails. Also, it detects the face image using Haar cascade algorithm and using Gaussian mixture model. Next, Gaussian mixture model. This GMM algorithm uses subtraction method, which is the most commonly used approach for movement detection. In this model, the moving object is detected or determined by comparing two frames. The previous frame is compared and subtracted with the current frame. Then it calculates the difference between the two frames. If the difference is greater than the threshold value, then it assumes that movement is detected. The Gaussian mixture model is parametric probability thickness that works as a weighted measure of Gaussian part density. It also stimulates a wide range of pixel types, and this model is used for modeling of a background is because that is one of the best model for background modeling. Next, Haar cascade algorithm. The algorithm uses edge or line detection feature proposed by Viola and Jones in their research paper, Rapid Objective Detection Using a Boosted Cascade of Simple Features, published in the year of 2001. The algorithm is given a lot of positive image consisting of face and a lot of negative image not consisting of any face to train on them. This algorithm has the OpenCV package for face identification where bounding boxes are formed around the face. Next, video surveillance system. Video surveillance is one of the fundamental subject in image processing. Video surveillance begins with simple CCTV framework to catch the information to the screen individuals. The investigation programming strategies video stream pictures to natural distinguish things. Next, face recognition. A great deal of study has been performed for automatic anomalous activity detection and preventing the situation like bank robberies. Computer vision techniques are used in a proposed methodology to recognize normal and abnormal human activities. The system consists of a framework where objects are shifting with respect to a fixed background. Conclusion. A message mention what type of alert is generated, and it also contains the face image of the thief and time detection with a web link where the live image is shorted so that the security can come with the appropriate preparations. Thank you.
Thank you, Yami,
Thank you.
for the presentation.
Thank you, ma'am.
Jay sir, next.
Yes. Next presentation is Sashi Mehrotra, and our paper title is a framework of a user interface COVID-19 diagnosis model. Sashi, are you there? Ma'am, I think she is not present.
Okay.
So we will wind up the session, madam?
Yes. One. Just a minute.
Yes.
All the authors have presented their papers nicely. But always remember, as a good researcher, we have to keep watching what are the updates in our areas. And according to that, we have to enhance our work. And thank you, GR Foundation, Amit sir, Aman sir, Richa, Hajalat Jay sir, for giving me an opportunity as a session chair in this 6th International Conference on ICT for Intelligent Systems. Thank you, sir. Thank you all the participants.
All the presentation is completed. I sincerely thank our authors for their excellent presentation in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. All the presenters will be getting their digital certificate through email within 2 working days. Further, all the papers I have already forwarded to the finger. The publication will be live within 5 to 6 months. Kindly cooperate with the team ICTIS 2022. I also thank our session chair, Professor Latika Desai. Ma'am, this is a token of appreciation on behalf of Team ICTIS and Global Knowledge Research Foundation. Thank you for your valuable time. Ma'am.
Thank you, sir.
And I request all the participants to turn on their cameras for a quick snapshot for this virtual conference. Kindly all turn on your camera for group photo. Thank you. Thank you, ma'am. Thank you all. Be safe.
Thank you. Take care, all of you.